In this part, we're going to introduce two theories that support the Arrhenius equation. First one is now collision theory, followed by intermediate activated theory. First one is collision theory. So Arrhenius equation is now became available by empirical relations between temperature and then reaction rate. The equation tells us the linear relations between natural log of the reaction constant K is equal to natural log of A pre-exponential constant minus activation energy over RT. When you put this into exponential form, K is equal to A pre-exponential form term multiplied by exponential negative activation energy over RT. Collision theory supports this Arrhenius equation theoretically. Most reactions requires collision between the reactants with enough energy and orientation. So collision should occur with enough energy, with high kinetic energy enough to overcome the energy barrier called activation energy and with the proper orientation. For example, we have like molecules within this reactor. With the given amount of temperature and the given condition, the molecules move with the kinetic energy, but they are not the same. The kinetic energy has some distribution, as you see here. At temperature 1, it is a distribution. Some of the molecules move very slowly, so with the low kinetic energy, small fraction. And some of the molecules move very fast with a high kinetic energy, also small fraction. Most of the particles move at the average kinetic energy or close to this average kinetic energy. Now, this is now called the activation energy right there. So, molecules should have more than this activation energy. Then this fraction of molecules, particles, have enough energy, enough kinetic energy to overcome this activation energy. When these particles collide with each other, then they make the reaction going to the product. Now we raise the temperature up to T2. Then this distribution of energy is now changing to a higher average kinetic energy of the molecule. So more widely distributed. Still, small portion of molecules are lazy enough to be moving slowly, and more molecules now have gained kinetic energy enough to overcome this activation energy. So more of them in that one. So in that way, because the fraction of molecules to have more than this activation energy is now increased, and it has more fraction, higher fraction of the molecules gain this much energy. So the probability to have reaction going to the product is increasing as like more kinetics increasing. So this one is now reflected in the equation of this Arrhenius equation. Arrhenius equation says that pre-exponential factor multiplied by exponential negative exponential over RT. This activation energy over RT. This portion, exponential portion, is now explaining the portion of like molecules, particles under the line over more than activation energy. So this one is now fraction of collision that occur with a kinetic energy in excess, more than the activation energy. So this one is now possible to overcome the activation energy, move on to the product side. Now this pre-exponential factor A is now explaining the frequency factor containing the information of collision frequency, how fast they collide with each other, and the orientation factor. Let's think about orientation factor. We have two modes of NaOCl molecules collide with each other, forming two modes of NO, nitrogen oxide, and chlorine molecule. So the orientation like this way: nitrogen at the center, and then oxygen and the chlorine at the terminal position like this way, with the little bit of bent position like this way. When they collide with each other with oxygen facing each other, then the reaction cannot occur because they need to form chlorine molecule. Chlorine needs to contact, in direct contact with each other to make a bonding, to form a bonding between chlorine, a single bond. When oxygen are facing this chlorine, in their collision, it is not an effective collision either. But when chlorine is now facing chlorine, they collide with each other with enough kinetic energy now, because this direct contact between chlorine, new bonding is formed between chlorine, and then old bond between chlorine and nitrogen is broken like this way. This one is now effective collision. This effective collision is now reflected in the factor, pre-exponential factor A. So this collision theory is now supporting how this Arrhenius equation formed and what is each factor means. The second theory is called transition state theory. When two molecules collide each other, activated complex is temporarily formed, and this one is now unstable, quickly disintegrating into the products. This activated complex formed when two molecules have an effective collision. For example, let's think about this reaction. CH3 and 3, this one is now reacting with each other, colliding with each other, and then forming CH3CN. So methyl cyanide is formed. So when these two molecules collide with each other, and the single bond between nitrogen and carbon becomes weakened, and this one NC group begins to rotate. And this one is fully rotate. A new bonding is formed between carbon and carbon single bond is formed, and forming a methyl cyanide, a product is formed. So the energy rate, energy level, this one is energy diagram of this reaction. This is x-axis shows the reaction progresses, and then y-axis shows the energy level, potential energy level. So the reactant energy level is here, and the reactant energy level here, and the energy difference is now this much. This is now exothermic reaction with delta H this much. And the activation energy is now energy level difference between the reactant energy, potential energy, and then this transition, this activation energy, the hill. And at the top of activation energy, this energy is now corresponding to the intermediate transition state. We call it transition state is now activated complex. The bonding between carbon and nitrogen is now starting to broken, and new bonding is starting to form between carbon. But the old bond is not completely broken. The new bond is not still fully formed. So in this transition state, the energy is high. Always in any change, transition state requires high amount of energy. So this one, unstable, activated complex. This one now, quickly, this one is breaking the bond of CN is now fully done, and the CC bond is formed, making the product. So this activated complex, this one. So what does it mean, this activation energy? Activation energy meaning the energy of this activated complex. And we need to go through this one and to making the product. So then transition state theory is also supporting the Arrhenius equation, and what does it mean, the activation energy. So this one also explaining what is the meaning of activation energy.